So now in this video, we're going to come up with kind of a scenario. Maybe we're going to light this bright LED right there module, and it kind of flickers because the power supply kind of cuts out if you bump it wrong. Maybe completely if you, really bump it wrong. But in any case, we got about 4.2 volts right there. That's what fully charged lithium ion battery would be. So this module is still not at its brightest. We can go up to 5 volts with this, not 14 volts though, with this entire circuitry. Let's get that down quick. So that's why you set a limit for the maximum current right there. And so I'm going to leave that blooper in there. That's exactly why I do that. So let's get back to 4.2 volts, as I said before. So that's like a fully charged lithium ion battery. Of course, we can go up, 1 more volt. It's a 5 volt module. And so 5.2 is probably still okay, I'm guessing. Let's get back to 4. And we're going to kind of quickly work our way down to 3 since we had distractions there. And, we should be pretty close to it being off there. We got about 17 milliamps of current flowing. And, it's higher than I would like. I would like it to drop right to 0 at that point. But fortunately, this circuit is not that good. Let's get this directly to the supply. And there you can see, we got, it looks like 37 milliamps of current. This isn't as good as a multimeter, but it's probably within 1 or 2. So 37 milliamps of current right there versus, let's see what that was again. And I don't think this will take too long. So wire up, 13 right there. So I think it's somewhere about a third, between a half and a third. I'll turn the power off. And first, we can zoom in. So I'm not using a 2N3904. I'm using a 2N2222 because this kind of has the current limit of what the 2N3904 would have. This can handle about 3 times the current, about 600 milliamps of current, the 2N2222. So collector base emitter, of course. Base is where we give our signal. So the signal has, first off, the base to emitter drop about 0.6 volts. And then the green LED, it's going to be about 2.5 volts at lower current. And this Schottky diode is probably somewhere around 0.3 volts, actually at lower currents. I'm guessing, probably between 1 and 2, 0.1 and 0.2 volts of drop that it has, I'm guessing. And that's stuff we could test later. So maybe I just took the 2.5 plus about 0.5 more there for like 3, and then thought this would get us, somewhat close to 3.3 volts, where current would stop completely. But again, at lower currents, they kind of let current trickle through more, and they don't drop as much voltage. But in any case, current's going to be set by the resistor there after that point as well. We need a fair amount of current because this is a bright LED when it's really bright. So that's another thing helping us out right there. Now this is made for 5 volts, so again, even at 3 volts, the current's going to go way down, but because you're getting to about the 4 voltage of the green LED anyways, so already it's got some built-in protection for this particular circuitry, but we added a little bit more. That's the main thing, and we could always modify this to be more effective, especially with like different loads, but I think this is a good demonstration right there. So again, the main takeaway is you need a little bit of base to emitter current to allow many times the collector to emitter current. The voltage drops. Take away, the voltage from the supply when it comes to the resistor. There's some of the voltage there, some of the voltage there and there. Less voltage across the resistor. But ultimately, whatever the voltage is across the resistor will end up setting the current